Okay, so we're literally split down the middle as far as answers. Who's right, Ricky or Rocky? So you could have done a couple things. You could have remembered the product rule as long as you did it correctly when we were working together, which the product rule says when you are multiplying things that have exponents in them, you actually add the exponents together. So Ricky said that 5 times 3 is 15. Rocky said 5 plus 3 is 8. So I would agree with Rocky because Rocky added the exponents, meaning I have 5 x's here and I have 3 x's here, and I have how many total? 8 x's. So that's exactly what that means. A lot of people, when they see multiplication, what do they want to do to the exponents? Multiply, but that only works for bases or big numbers. It does not work for exponents. Exponents, you have to add them. Just like when you're having two things with exponents divided, what do you do to their exponents actually? You subtract them. So we're going to look at all these different rules for exponents. So I could have just written out 5 x's and 3 x's and notice that there were 8 x's total, but there are all these different rules that we can go by that kind of give us a little bit of a shortcut. So we're going to talk about those. You looked at a couple of them, but we're going to talk about all of them together. So you need to be on page 6 in your Algebra Nation book, please. Page number 6. Okay, so before we just start talking about exponents, it would really help if we knew what an exponent told us to do. So this 4 right here, we have 2 to the 4th. What is that 4 telling me to do? Yeah. Right, the number of times I'm going to multiply that base together. So in this case, we're multiplying 2. We're multiplying 2 together. 2 times 2 times 2 times 2, 4 times, because it's 2 to the 4th power. And we can calculate that really quickly. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 again would be 16. So that's what 2 to the 4th power would equal. So thinking about that, 2 to the 3rd power would be 2 times 2 times 2, which would be 8. 2 to the 2nd power would be 2 times itself, which would be 4. So what is 2 to the 1st power telling me? Just 1, 2, right? I'm not necessarily multiplying it by anything. I just have 2, just one of them. So what do you notice? What's happening to my answers? I went from 16 to 8 to 4 and then to 2. What's happening each time to my answers? Yeah, Kendrick.
It's divided by 2.
We're dividing by 2. So we are dividing by 2 every single time. You could also say splitting in half. That's the same thing as dividing by 2. So this isn't a question, but I just want to talk about this one. So if we have 3 to the 3rd power, 3 times 3 would be 9, times 3 again would be 27. 3 squared would be 9. 3 to the 1st would be 3. What are we dividing by this time? 3, right? Why do you think on the first one we're dividing by 2, but on this one we're dividing by 3? What's the difference between the two problems, Allie? The base is different. You're going to divide by whatever the base is. In that case, it was 2. In this case, it was 3. So if we continue that, what would 2 to the 0 equal? Oh, someone says 0, someone says 1. Why do you say 0? Am I? Go ahead, Brianna.
It's 1.
Why?
I remember one of the rules on the worksheet.
Yeah, but I agree. Yes, you're right. But following this pattern. So we went from 16 divided by 2 was 8. 8 divided by 2, 4. 4 divided by 2. 4 divided by 2. Come on, we know that. 2. So what would 2 divided by 2 be? 1. As our exponents get smaller, our answer is being divided by 2. So this is the zero exponent property, which means any number in the whole wide world, if we raise it to the 0 power, the answer is always going to be 1, no matter what. I know 100% when we get to a test or a quiz, what's someone going to answer?
0.
And it's just going to make me, it's 1. 1, 1, 1, 1, 1, 1. It's 1. Okay. Don't, please. If you remember nothing, remember that. So continuing that, actually, I'm going to write it over here just so I can fit it on one screen. So we had 2 to the 4, 2 to the 3rd, 2 squared, 2 to the 1st, 2 to the 0. And we figured out that all of those equaled 16, 8, 4, 2, 1. What would 2 to the negative 1 equal? Keep the pattern going. Oh, keep the pattern going.
2.
So we're dividing by 2 still. Yeah, 0.5, but I speak in fractions. So what would that be as a fraction? 1/2. So if we are dividing by 2 every single time, 1 divided by 2 would be 1/2. So continuing the pattern, what would 2 to the negative 2 be? 1/4. How'd you get 1/4? 1/2 divided by 2, right? So what would 2 to the negative 3 be? Close. 1/8 divided by 2. I want you to notice something. 2 to the 3rd is 8. 2 to the negative 3rd is 1/8. 2 to the squared is 4. 2 to the negative 2 is 1/4. 2 to the 1st was 2. 2 to the negative 1 first, negative 1 is 1/2. So all you're doing is you're taking that positive exponent and you are turning it into the reciprocal. So for example, what if we had 3 to the negative 3? Before you do anything, what would 3 to the positive 3 be? So 3 times 3 is 9. 9 times 3 is 27. But we want to take this 27 and we want to put it in the denominator under a 1 because that exponent is a negative. You are not allowed to have negative exponents. The reason why is exponents tell you how many times you're going to multiply something by itself. So how can you multiply something by itself -3 times? You can't, exactly. So we have to change the look of the problem to be able to say that we're multiplying it by itself so many times. We can do that by changing it to its reciprocal. So we said 2 to the negative 1 was 1/2 and 2 to the negative 2 was 1/4, which is the same thing as moving this to the reciprocal. 1/2 to the 1st or 1/2 squared. Those are the same thing. So all we did was we changed it to the reciprocal and made that negative exponent into a positive exponent. And that's called the negative exponent property. So here you can see that that exponent is negative. So what we can do is we can change it and put it in the denominator or the reciprocal and make that exponent a positive. The opposite is true. If it's in the denominator and it's negative, I can move it up to the numerator and change that exponent to be a positive. And that's called the negative exponent property. All right, let's look at a couple more rules. So the product property was the first one y'all looked at. You may have looked at it on Thursday. It's saying when I add or multiply 2 things that have the same base. When I say base, I'm talking about that big number. I can add their exponents together. So 2 to the 3rd times 2 to the 4th would give me 2 to the 7th power, not 2 to the 12th power. Because if I sat here and wrote this out, it would be 2 times 2 times 2 times 2 times 2 times 2 times 2. Did I do that right? Yeah. And that would be 1, 2, 3, 4, 5, 6, 7 twos. So that translates to 2 to the 7th power. Same thing goes over here. Right now, I have a negative exponent. That's okay until I get to my answer. So we want to add 5 and negative 3. That would leave us with 2 to what power? What's 5 plus negative 3? 2, right? So 2 squared, which I know you can calculate as 4, but I'm not worried about that right now. Same thing goes for variables. So I have an x to the third and an x to the second. I could add those two things together to give me x to the 5th power, x to the 5, or x to the 5th power. So anytime you are multiplying, we can add their exponents together. So here I have an m and an n, and if I add those, it would give me my answer as long as the bases or the big numbers are the same. The opposite is true for the quotient property. So instead of adding, we want to do what? Subtract. So I have 4s here. I want to subtract their exponents. 5 minus 3 would give me 4 squared. Seven minus 8 is going to give me x to the negative 1, but I just said that can't be our answer. So we want to take that and we want to put it in a denominator under 1 and change it to a positive. So negative x to the negative 1 is not wrong, but it's not a proper answer. Your answer has to only consist of positive exponents. So to change that, we can change it to its reciprocal. So when we're dividing, we want to make sure that we are actually subtracting their exponents. And let me show you what that looks like. So for the first one, I have 5 4s in the numerator. So 4 times 4 times 4 times 4 times 4. In the denominator, I have 3 4s. And this was that little section that said cancel. When I sent it to you, it should have had lines through it, and I apologize, it did not. But what cancel means is we can get rid of stuff that matches on the top and matches on the bottom. So I have a 4 here at the top. I can cross that out because it matches with that 4 in the denominator. I have another 4 here. I can cross that out with the 4 it matches in the denominator. And then I have those 2 4s that can cross out. There's nothing else I can cancel. So how many 4s are you left with? 2. And that's where that 2 comes from, 4 squared, or 4 to the 2nd power. Good. Okay. Last property that just deals with one base. So I have 2 exponents that are like touching each other. Notice the difference here. This one had 2 bases, the same base multiplied together. This just has 1 base that's raised to another exponent. What you're going to do is you are going to multiply those 2 exponents together. So that would give us 5 to the 3 times 2 would be 6th power. This one we're going to multiply. 4 times 3 would give us y to the 12th power. I kind of remember this one, and those 2 exponents are like touching each other. And when things are touching each other like that, we use the operation of multiplication. So we have a to the m times n. I use that dot for multiplication. Any questions so far? You guys looked at most of these when you were working together. I just wanted to like get a clarify them if you had questions. Okay, so 2 more, which are similar to the quotient and the product property, but now we have 2 bases, 2 big numbers. So I want you to think about this like the distributive property. We can distribute that exponent to both of those things inside the parentheses. So that would give us 2 squared times 3 squared, and I'll give you a moment to figure out what that equals. I want you to get a final number answer. So 2 squared times 3 squared. For 2 squared, 2 times 2 was 4. 3 squared, 3 times 3 was 9. 4 times 9 should have been 36. Now, go back to the beginning of that problem. What's 2 times 3? What's 6 squared? 36. 6 squared, 6 times itself would be 36. So either way would be correct to solve this one. I just wanted to show you that that property works. You can distribute or give that 2 to both of those things. So the next one, we're giving a 3 to a 4 and an x. So 4 to the third and x to the third. And again, I'll give you a moment to figure out what 4 to the third is. 4 to the third was 4 times 4 times 4, which is 64. Good. And then x to the third, we can't do anything with, so we'll just leave it as x to the third unless I told you for some reason whatever x equals. So if we have an exponent outside those parentheses, we can apply it to everything that's inside the parentheses. So that would be a to the n, whatever n would equal to, and b to the n. And again, same thing goes for quotient. We can give this squared to the 20 and the 3. So we would have 20 squared in the numerator and 3 squared in the denominator. 20 times itself, 20 times 20. 400. And 3 squared would be 3 times itself, which would leave us with 9. Now, how do I explain this? Who's heard the term improper fraction before? Okay, I do not like that term because when you hear the word improper, what does it make you think? It's not correct. That is a completely acceptable answer for Ms. Simpkins. I do not want you to turn that into a mixed number. I don't want you to give me a decimal. I want you to leave it as 400 over 9. The only thing that I may make you do at some point is if you could simplify it, like if it was 400 over 15 and like 5 goes into both of those things, that may be something I ask you to do. But I do not want you to do that, especially because when I take 400 and divide it by 9, it's a repeating decimal. And you can't accurately describe that to me. You can accurately describe 400 over 9. So please leave it as an improper fraction. I don't care that it's 40. I think it's like 41 and 4/9 or something like that. Don't care. I want you to leave it like this, okay? I call them fractions of greater than 1. Has anyone ever heard that before? No? Okay. Improper just always has a negative connotation. You think like improper is wrong, but leave it as an improper fraction. So same thing here. So 6 to the third over y to the third. 6 to the third is 6 times 6 times 6, which I'll just let you know is 216 over y to the third. So whenever we have a quotient and we have an exponent that's outside those parentheses, we can give that exponent to both the numerator and the denominator to get our answer. All right, so let's actually solve some stuff. So we're just going to do the first one here because I want y'all to get to the matching problem in a second. I want to give you some time to work on that one. So are the two sides of this equal sign true? So if we look at the left-hand side, we are multiplying them together. So that means we do what to their exponents? Add them. So 3 plus 4 would give us 3 to the 7th power. On the right-hand side, we're dividing. So we do what to their exponents? You got this. Subtract them. So 9 minus 2 would also give us 3 to the 7th power. So these are equal to each other. So I would consider that true. Both sides of those equal signs are the same. We're going to skip letter B. I don't like letter B. So what I would like you to do over the next, we'll say like 4 or 5-ish minutes, is I want you to answer the try it question and the beat the test question. So the try it question is matching. You can use lines to match if you want to do that. You can write the right letter next to the right number. So the left-hand column matches one of the answers in the right-hand column. You do not have to like go like solve all the way for a number. You can like use one of the properties to be able to match the ones in the left-hand column to the right-hand column. And then you can answer those two parts on beat the test. Okay. Okay, so first thing I want to look at is the matching portion. Good job, Madison. So the first one was a quotient division problem with an exponent outside the parentheses. So that means we can give this exponent to the numerator and the denominator. So that would give us 7 to the 4th over 2 to the 4th, which was the second one. So I'm going to draw a line. Actually, I'm going to write this over here. This was 7 to the 4th over 2 to the 4th. So A went with number 2, which I saw a lot of you do. B, again, I have that exponent outside the parentheses, so I want to give it to both of the things inside the parentheses. So that would be 7 to the 3rd times, and then 2 times 3 would give me 2 to the 6th power, which was the first one. C, we want to add those exponents together. So 2 plus 2 would give me 7 to the 4th power, which was the 4th one. D, 7 to the 0. What's anything to the 0? 1. So essentially this doesn't really matter. We're just left with 7 squared, which was the 5th one. I'm going to jump down to the last one before I talk about to the -4. So 6 minus 3, remember we want to subtract those exponents. So that would be 7 to the 3rd power, which was the last answer. And by process of elimination, I hope that you found that E went with the 3rd one. But because it's to the -4 power, we have 7 to the -4 over 2 to the -4. But I talked about if they're negative, we want to flip it or multiply by or change it to its reciprocal. So the reciprocal of this would be 2 to the +4 in the numerator and 7 to the +4 in the denominator. And that's how you get that answer of number 3. Beat the test. At least everybody I've checked so far has gotten the right answer, or we got to the right answer. So the first part was Crosby, because Crosby added those exponents, and the second part was Adam because Adam subtracted the exponents. So A was Crosby, B was Adam. Okay, I want everybody to go to their Canvas, and I'm going to show you where to find everything you need to be able to do your test corrections. If you want to write this down, I have it in Canvas too, but your test corrections are due next Tuesday because that's the next time over a week that I see you. The sooner you turn them in, the sooner I've already gotten some from people from Friday that I've changed their grade. Everybody's eligible and you can get half of your points back. So the test is out of 51 points. So if you got, say, a 30 out of 51, you can get 10.5 points back, which would make your grade, as long as you do them all correctly, 40.5 out of 51. I will tell you that the people that have turned them in have made their overall grade go up by like 4 or 5%. Because like that's the biggest grade that we have in this class right now is that test. So if you are in Canvas and you go to, actually, let me go to student view here first. Go ahead and go to your modules and you want to find the test. Don't click on the test corrections yet, just click on the test. So if I go to student view, go away, thank you. Why is it important that I put the test there? Yeah, it'd be really hard for you to like know what to correct when you don't even know what the questions are, right? So I uploaded a copy of the test. It should be under module 1, like almost to the bottom. And on the right, you should see I don't see it on mine because this is like the fake student, but on yours, you should see like comments on the right-hand side. Does anybody not see like comments on the right-hand side? In those comments, you should see what you answered And it should also tell you 0 out of 3 points or 3 out of 3 points. If you got 0 out of 3, what does that mean? You missed it. If you got 3 out of 3, what does that mean? You got it correct. So that is a way for you to see the test questions and then see which ones you got right or wrong. Sammy, are you good?
Yeah.
Okay, I just want to make sure. Yes.
So it's gonna be the same test?
You're correcting it. You're not retaking. I do correction. Some teachers do retakes. I just do correction. So let me show you what you're actually going to like turn into me to get your points back. So obviously you'll need this page, and it may be helpful for you to like open it in 2 different tabs. But if you scroll down and hit next, you should see a document that might take a second for it to load. So this document is very important, and I will not give you full credit unless you do this correctly. So in column number 1, what should you put? What does it say? The problem number. And column number 2, I actually want you to write what the correct answer is. If it was a multiple choice, it would be very helpful for Miss Simpkins if you wrote the letter of the answer too. The biggest thing that people mess up is column number 3. If you do not do column number 3, I will not even look at your corrections. Column number 3 is what mistake did you make? And something that will help you remember that in the future. Those things need to be included for you to get your points back. Does everybody understand? Okay, now, obviously, if you got it wrong the first time, you may not know how to get it right the second time. You can ask Miss Simpkins. I am available this week. I'll say Wednesday morning and my normal Friday mornings before school. I can work on them with you guys then. And since y'all's isn't due until Tuesday, next Monday morning, I can sit in here with you before school and work on these test corrections. You're welcome to do them in your own time, but I've already had people turn them in and not even correct them to the correct answer. So I'm not going to give you the points back if your correction is not correct, right? So you have about 10 minutes left of class. You can work on this. You can work on your homework tonight, which is homework 11. Digital students, make sure you heard that, homework 11. Or if you weren't able to finish the exponent rules exploration up to power rule, you can work on that. So you got 3 things that you can be doing over the next 10 minutes. Does anyone have questions about the test corrections themselves? Okay, whenever you're ready to submit, y'all should have a blue button right in the top right-hand corner that says submit. Make sure you do that.